what answer did we get for that problem? I think it was this one. Ten pi over 6 is too big. Yep, 5 pi over 6. So I'm assuming you probably subtracted over here. So you got 2 sine x is equal to 1 divided by 2. Sine x is equal to 1/2. And then got that x was equal to pi over 6 plus 2n pi, and or 5 pi over 6 plus 2n pi. All right, solving on an interval specifically. So these ones say solve on the interval from 0 less than x less than 2 pi. So that means that we're not doing the plus 2n pi part anymore. It'll just be the numbers off of the unit circle. So 5 plus 2 sine x minus 7 equals 0. So what do I need to do first? Yeah, so that'll be -2, so I'm going to move it over as +2. So 2 sine x equals 2. Divide by 2, so sine x is equal to 2 over 2, which is 1. So I'm looking for where is the sine of x equal to 1. Where's y1?
It's 2, 2
Pi over 2. Now these ones, because they're specific solutions, this is where we need to plug them back in to check, okay, to make sure that it's not extraneous. Now, obviously this one only has one answer. Some of them will still have 2. It's just the nature of this particular problem. So 5 plus 2 sine of pi over 2 minus 7. So 5 plus 2 times the sine of pi over 2 is 1 minus 7. So that's 7 minus 7, so 0 equals 0. So we're good there. Let's see, 20. 5 tangent squared of x minus 15 equals 0. So still a specific solution on that interval. So I'm going to add the 15. So 5 tangent squared of x equals 15. Divide by 5's tangent squared x equals 3. Now what? Okay, yeah. I don't have to write it that way, but if you need that for a visual, that's fine. That's just a notation thing.
It'd be tangent x square root.
Plus or minus the square root.
Okay, so tangent of x equals plus or minus square root of 3. So I'm looking for everywhere that happens from 0 to pi over 2. So where does that happen?
3 pi over 3. 4 pi over 3.
Where else?
Oh, and 5 pi over 3.
And
2 pi over
2 pi over 3.
Oh,
Now it was only that because it was plus or minus. Okay, so we had 4 answers. Normally we only end up having 2. Now technically I should check all of them, but I know that it's going to end up working because all of those give the square root of 3, which squared is 3 times 5 is 15 minus 15 is 0. So I know that all of those work. Now, you won't often have one that doesn't work, but you just need to look at it and show. So, like, if you did that, I would just make a point to show that you did check them, even if you don't write it down. Because, I mean, I don't need to see all 4 of those right now. Just let me know that you did at least check them. So, are we okay on those?
yeah.
Let's see. I think that's actually all we're gonna do with that section. We not really anything else we need to do on this one. I'm not gonna give you any that are like secant, cosecant, or cotangent in terms of solving. The only ones you might have with those trig functions are the ones where you have to plug in the number for x or theta. So if we're good, then problems are going to be 5, 7, 9, 11, 13, 17, and 21.